More and more demands are being made on soybean.
We believe research is the future of the soybean industry.
Soybean technology offers the hope of dealing with many of the nutritional and health problems we see too often in the world today.
Drought is a leading problem in world soybean production.
If scientists could change the quality of soybean oil, the positive benefits to human health would ripple through our food system.
Most farmers in Missouri know that 95% of our market lies overseas. Soybeans are our most important export. They are the most important crop that we grow in Missouri. And the more and better soybeans we can make, the more that we can improve our balance of trade, improve our incomes here in the state of Missouri, and help our economy grow.
Soybean, like any other crop, has a given genetic diversity that can be improved by the use of its white ancestor in order to get products that have a better quality for animal feed, human consumption, and industrial products.
We're doing research in soybean biotechnology to deliver it for the benefit of farmers and the consumers that use their products.
What it took was a new type of professor. And from the endowed professors that were paid for by the checkoff funds, we're able to go out and identify absolutely the best in the country and attract them to the University of Missouri.
We're really focused on important agronomic traits, things such as stress tolerance, tolerance to things such as drought.
We are studying the mechanism of drought resistance to identify specific gene and genetic technology.
Because of its widespread distribution, prolific reproduction, and long-term survival mechanism, soybean cyst nematode remains a serious threat and is considered the #1 pathogen of soybean. The average bushels of soybean lost to soybean cyst nematode in the United States is 128 million bushels annually, and this loss is valued at $1.2 billion.
We're also focused on seed traits, oil and protein, which is really the ultimate product of the soybean.
The questions we ask now is, how can we take soybean and maybe take components out of that soybean and use them for functional food properties?
And one of the targets that we have is to increase the functionality of the oil by creating an oil that has high oleic acid.
As a breeder, it's my job to give a farmer a variety that he can be confident in. The bottom line, though, is yield.
I preserve the genetic traits of those soybeans so I can guarantee that the end user gets the exact genetic trait that I grow.
The NCSB cracked the genetic code of the soybean.
So now that we have the complete genome sequence, we have many, many more markers, and we can much more accurately map these kinds of traits. And that really speeds up the breeding process.
Where it took 7 to 8 years to develop a variety, now it only takes 5, because we know where the genes are, we know how to keep the yield, and a farmer can be confident that he's going to get a good variety to grow on his farm with the traits he wants.
The genome sequence is also allowing us to look into other aspects of soybean function.
The real breakthrough came when we discovered that if we took genes from 2 independent lines and put them together through conventional plant breeding techniques, we could create a soybean line that had the desired oil profile, a high oleic acid oil profile. And this is similar to olive oil, a very valuable oil and functional in foods.
We're trying to create a deeper root system which will help the plants to absorb more water in the soil.
We are targeting genes that are highly specific to plant parasitic nematodes to decrease possible off-target effects and increase durability by targeting genes essential for nematode parasitism.
I'm working on the early interaction between the rhizobia and the soybean. When the rhizobia interact with the soybean root, it can form a new organ, we call it nodule. It can fix nitrogen from the air and transform it into the form that the plant can use, so that we don't have to use fertilizer.
The research we've been doing recently involves how we improve feed efficiency using soybean meal. Our interest there is how we can take soybean meal, process it such that it allows us to take roughage out of the diet of feedlot cattle and also increase the amount of amino acids that they're able to consume and digest. The result is we can reduce waste excretion by 40 to 60%, and we improve feed efficiency by 7/10 of a pound of feed per pound of gain or better in cattle.
When you look at the progress that's already been made in soybean technology here at the National Center, you can be really excited and say this is great. But what I'm more interested in is the research that's going to happen in the future. We set up this center not to just do a few years, we set it up to continue to develop and produce.
So when we think about the future, the question is not just using the protein in soybean meal, but what can we get that soybean plant to produce that gives extra or added benefits to the animal.
And in soybean, we estimate maybe 45,000 or more different genes, and we know very little about the function of those genes. And so one of the other projects that we have here at the National Center for Soybean Biotechnology is to make a mutation in every soybean gene. And then once we make those mutations, we can see what their effects are.
If we can grow a genetically based soybean that has more extractable content that our processors are looking for, then that should add value back at the fields.
Our goal is to develop every single soybean variety in the U.S. that will be more drought tolerant.
Ultimately, we hope to broaden resistance to target all nematode races.
I safely place my bet on Mizzou continuing to be the leader in plant biotechnology.
I believe the soybean is the miracle crop.
We're all about making a better soybean.
Molecular markers and other genotyping technologies will accelerate the development of new soybean varieties.
And it all starts in the pioneering work that's been done in soybean biotechnology.
Biotechnology really is the hope for the future.